So here we're looking at the rate of change. So the rate of change is a ratio comparing the change in the dependent or y variable with respect to the change in the independent or x variable. So it compares how something's going up or down, if it's increasing or decreasing, how much compared to the change in the horizontal movement. And so we'll look at some examples that'll hopefully clarify that a little more. So the rate of change is often formulaically described as the rise over the run. And so this one's important to remember. You're going to use this in grade 9, 10, and so on. So the rate of change of a graph is the rise over the run. So how much does it go up or down over how much does it go left or right. This is often called the slope. So we often use the term slope when we're working with this. The activity sheets I have don't just, I believe, use rate of change only, but oftentimes your teachers will call it the slope as well. Just to note, this y variable here, the change in y variable, that's going to be the rise. The change in x variable, that's going to be our run when we're relating them. And so we can use what's called a rate triangle to show the rate of change on a graph. So if I have a graph here, no numbers or anything, just a general concept here. So I have a graph, I got a line, and I can pick 2 points on the graph. So I got a couple labeled here. I'm going to pick this point and this point here. And what I do is I make a triangle. All right, so I make a right angle triangle between those 2 points. And I can use that triangle then to illustrate the rise and run. So this part here is the rise. Is the graph going up? How many spaces? How much distance does it go up? And this part here is that run. So the change in the y or dependent variable compared to the change in the x variable over that interval. And so we'll work with some examples here to help better understand what's going on here. So if we're working in the case of a table and we're looking at those changes, the first couple examples are tables. So we have a table here. Our x values, -2, -1, 0, 1, 2, 3, and then the respective y values, 7, 11, 15, 19, 23, and 27. We need to find the rate of change. So it's the change in the y variable with respect to the x variable. So as we did before when we were looking at how these graphs, these linear relations were moving, I'm going to do a little jump illustration here. When we hop from one point to the next, we're increasing, in this case, +3. And then +3, +3, +3, and +3. So those hops, those illustrate our change in the y value. Every time we're increasing by 3, and with respect to x, so each x value, each time we're increasing +1. So each time we're going up by 3 here, each time we're going up by 1 here. So in that terms of that rise over run, this is our rise because it's on the y, the vertical axis, and this part over here represents our run. So the formula being the rate of change, I'm just going to go R of C equals rise over run. Thus, if our constant rise is 3, +3 over +1. So our rate of change is +3 over 1, or just 3 over 1, or you may even see it written as just 3. Because 3 divided by 1 is 3. So that would be the rate of change of this first table here. So we do the same thing in our next table, is we look for the differences in each set of terms. So in the case of x here, I've done the same thing, and I've gone up by 1 each time. +1, +1, +1, +1. And these plus jump bubbles are just there to kind of illustrate what's going on. But again, that's our rise. It's a constant rise of 1. And then we have a constant, a constant run of 1, our rise over here is now a constant drop by 2. So even though we use the term rise, we can rise in a negative fashion, and then that means we're going down. So in this case, we're going down by 2. Our rise is negative 2, and so our rate of change, R of C, is, again, the rise over the run, which in this case is negative 2 over positive 1, which just works out to negative 2 over 1, or negative 2. So to get the rate of change from given a table, we just compare the two values, x and y, or whatever our horizontal and our vertical terms are, and we put the vertical on top over the horizontal, and we get our rise over run. So that is an example of one situation. The other case is we may want to get the use the rate triangle to calculate this. So if we're given a graph and we want to calculate the rate of change, then we need to find some points on that graph and create a rate triangle. When you're picking points, it is important, and I've illustrated the first pair here, to pick points that intersect at the grid lines. So this here, picking a point right here, that's a bad idea. This is a bad point because you don't know exactly where that is. Is that at 3.5? Well, it's kind of, but we don't know exactly where it is. Where if I pick this point here, well, it's right at 3 and 20. I know exactly where it is. I can tell you the exact numbers. So when you're picking points, pick points where the graph crosses a grid line. Don't pick this point. Don't pick this point. This is a good point. 0 and 10 would be another possibility for our graph. So these are there's 3 possible points I could pick. I need 2. Doesn't matter which 2. I'm going to pick the 2 close ones here. And what I'm going to do is draw my rate triangle. So I'm going to try and use this blue, and hopefully it shows up a little bit. So that is a right angled triangle. But I'm going from left to right. Remember, we read the graphs from left to right. From left to right, I'm going up 1, 2. So plus 2 is my rise. 1, 2, 3 squares over. Plus 3 is my run. Now, that right there makes sense in terms of squares. However, there is one slight omission that I made. Looking at the scale, it's important to look at the scale on your graph. The scale along the bottom, it's going up by 1, so that is actually 1 unit, 2 units, 3 units, from 3 to 6. However, here it goes up 2 squares, but it's not going up by 2. It's going up 20, 25, 30. It's actually going from 20 to 30 in this case. So this value here, this plus 2, is not what you actually want to put. You actually want to put plus 10. Okay, so we're going up by 10 in this case. So our rise is actually 10. So you got to be careful when you're looking at the graphs that you actually look at the scale. Sometimes we'll have tricky scales like that, depending on the situation. And so you need to read that. So now I have my rise and my run. And again, the rate of change is equal to the rise over the run. And my rise is 10 and my run is 3. They're both positives. So 10 over 3. I don't convert this to an improper fraction. So as an improper fraction, this would be 3 1/3. When we're working with rate of change, when we're working with rise over run, we leave it as the fraction because the fraction tells us 2 things. It tells us the top number tells us the rise, the bottom number will tell us the run. And when we get later into using this information to graph, it's easier to graph this than to try and graph 1 1/3 going up by that fractional portion. These are whole numbers. We can rise up, count up 10. We can count over 3, and it works out. So make sure you leave it as a fraction. And again, pay attention to our scale. So in this case here, we just have a standard XY graph. And so let's look at our scale. Our scale here, 1, 2, 3. So it's going up by 1s along the x-axis. It's going up by 1s. Every square is a 1 along the y-axis. I've just labeled every second point, but each square is 1. So we're good there. We can just count the number of squares. Now we got to pick some points. So if you notice, this is a great line because there's a point here, 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 and here. All these points where it's crossing the grid lines, we can tell exactly where they are. We're not sure exactly if that is a half, but we can tell this is exactly at 1 and 2. So this is a good point. And I could pick any points. I could pick the next one here. I'm going to pick down here maybe. Let's pick right here. -2 and -1. So there's 2 points. And I'll draw my right triangle. I like drawing it on top like I did before. You can draw it underneath. It doesn't make a difference. Whichever way is actually more convenient for you. But I like drawing them on top. As long as we're connecting our 2 points, it doesn't make a difference. The rise will still be the same. The run would still be the same. So in this case, I'm rising up. And again, each square is 1. 1, 2, 3. So my rise is +3. My run is 1, 2, 3. My run is +3. And so now I have a rate of change. That is the rise over the run, which is 3/3. 3/3 simplifies down to 1/1, or just 1. So we always want to simplify that down. So from each point, my rate of change, I go up 1, I go over 1, I go up 1, I go over 1, I go up 1, I go over 1, I go up 1, over 1. It's like a little staircase. The one example I didn't show you, and maybe I'll do a little one right here. Let's do one like this. I'm going to do it in blue this time. Because I didn't show a negative, and I would like to show a negative slope. Connect the points here properly. There we go. So using this line down here, okay? So this is going to be line C. We'll call this one C down here. So 2 points, 2 good points. One's here. Following the line, I had made another one here. And to get the rise over run of this C line here, the rise and run triangle is right here. So it's relatively lengthy, but a short rise. So the rise is actually going down. And see, I made the triangle below. It doesn't make a difference. But when I go from left to right, I'm going down 1. So this is actually -1. And then I'm going over 1, 2, 3, 4, 5, 6. Always leading from left to right. So this is +6. So there's my rise of -1. There's my run of +6. So in the case of C, the rate of change is the rise over the run, which is -1 over +6. -1/6 is our rate of change. And again, we leave it in that fractional form like that. So that's a gist of rate of change, also known as slope. It's rise over run. You can use the unit triangle on the graph and count between points. Again, with the graph, be careful of your scales. And if you are going down, again, we're always reading from left to right. If you're going down, then it counts as a negative value. We're going down by 1. In the case of a table, again, you can just count the rise off the Y column or the dependent column, and the independent column will count the run. And then it's, again, the same. It should be constant in a linear relation, and then rise over run. And that's about it for rate of change.